Example 30. It says, find the volume of the solid generated when the region bounded by the curve y is equal to 2 sine x, the line y is equal to 1, x is equal to pi by 6, x is equal to pi by 4 is rotated through 2 pi radians about the x-axis. All right, so let us try and see if we can find the point of intersection of the two curves. So looking for point of intersection, or points of intersection. All right, at the point of intersection, y for two, the x coordinates and y coordinates are equal. So for one curve, this y is equal to 2 sine x. For the next one, y is equal to 1. At the point of intersection, those two are equal. So now we have sine. If I divide both sides by 2, I'm going to have sine x is equal to a half. Now, if I know the sine of an angle to find the angle, I'm going to use sine inverse. So x is equal to sine inverse of a half, which is equal to pi by 6, or 30 degrees. So at the point of intersection, I can now try and see if I can draw a little sketch. I have my y-axis. I have my x-axis. So y is equal to 1, y is equal to 2. This would be the line y is equal to 1, so that's one graph I drew. Let's say this is pi by 6, and let us say that this is pi by 4. All right, our graph, I have to bear in mind that the two graphs intersect at x is equal to pi by 6. Now our graph is going to look something like this. All right, and so somewhere out here where x is equal to, let's say, pi by 2, sine of 90 is equal to 1, and 2 times 1 is 2. So our graph would probably look something like this. All right, and the region we're looking for is bounded by the line x is equal to pi by 4. So the region we're going to be generating is this region here. All right, and that region is bounded by x is equal to pi by 6, x is equal to pi by 4. The graph of y is equal to 2 sine x, and y is equal to 1. All right, so the volume that we're looking for is going to be equal to pi, the integral from pi by 6 to pi by 4 of y squared, y squared being 2 sine x, that's y, square dx, minus the integral from pi by 6 to pi by 4 of y squared, which would be, all right, and we must not forget the pi here, of 1 squared dx. All right, of course, we're going to find them one at a time. So the first piece is pi, the integral from pi by 6 to pi by 4 of 4 sine square x dx. Let's pull the 4 to the front. We get 4 pi, the integral from pi by 6 So pi by 4 of sine square x dx. All right, so let's try and create a list. Let's try and see if we can do some more of it on this page before we turn the page. So this would be equal to 4 pi. Now we have to remember that sine that cos 2x is equal to 1 minus 2 sine squared x, and that sine x would therefore be equal to 1 minus the cosine of 2x divided by 2, and so our integral will be equal to 4 pi, the integral of 1 minus cos 2x all over 2 from pi by 6 to pi by 4, and we are integrating with respect to x. We can pull the 2 out, so we get 4 pi over 2, the integral from pi by 6 to pi by 4 of 1 minus cos 2x dx. All right, and I guess now we could turn the page. So this would be equal to 2 pi, because 4 pi over 2 is 2 pi. And let's integrate. When we integrate 1 with respect to x, we're going to get x. When we differentiate sine, we get cos. If I integrate cos, I'm going to get back sine. So it's sine minus sine 2x divided by the differential of the inside function, which is 2. And of course, our limits are from pi by 6 to pi by 4. So this is 2 pi. First, we're going to replace x with pi by 4. So it's pi by 4 minus the sine of 2 times pi by 4 all over 2 minus, then we're going to replace x with pi by 6. So it's pi by 6 minus sine of 2 times pi by 6, and this is over 2. All right, so this is 2 pi. Over here, we're going to have pi by 4. 2 times pi by 4 is pi by 2. The sine of 90 is 1. So this becomes minus 1 over 2. And over here, we have pi by 6. This is 2 times 30, which is 60. And the sine of 60 is root 3 over 2. So this is minus root 3 over 2 divided by 2 becomes root 3 over 4. And so this becomes 2 pi. Let's try and, this becomes pi by 4 minus pi by 6 minus a half plus root 3 over 4. All right, so let's simplify inside of the bracket a little. So this becomes 2 pi. The LCM here would be 12. 4 into 12 is 3. 3 times pi, 3 pi. So it's 3 pi minus 2 pi, which would just simply be 2 pi. 4, 3, 2 pi would simply just be pi. So it's pi by 12 minus a half plus root 3 over 4, and this is cubic units. All right, let's work with that last piece. Now, the last piece is the integral from pi by 6 to pi by 4 of 1 square, which is 1, dx. So, of course, pi at the front. So now we have pi, and this becomes x from pi by 6 to pi by 4. So first we're going to replace x with pi by 4, and then with pi by 6. So now we're going to have pi, and then we have pi by 4 minus pi by 6. 12 being the LCM, this our final value would be pi multiplied by pi. So it's pi into pi by 12. All right, and of course we're going to subtract the two volumes. So our volume is going to be it's going to be 2 pi by 12 minus minus a half plus root 3 over 4, and this is minus pi into pi by 12. All right, so let's see if we can simplify it a bit further. Pushing this 2 and then factor out a pi. So we have pi here, and then this becomes pi by 6. So I'm applying distributive law and factorizing at the same time. Minus 1 plus the root of 3 over 4, and then minus pi by 12. And so this is pi. This is 2 pi by 12 minus pi by 12. So I have pi by 12. So it's pi by 12 minus 1 plus root 3 over 4. And this is cubic units. All right. And so this is our answer. All right, it's not necessarily a pretty answer, but it should be accurate nonetheless.